astronauts, Michelle. I don't know if many of you realize, or a lot of you are in the group, because I did do the book, You Can't Get to Mars Without Me, The Rules of Gravity. But I really want to talk about, especially since, William Shatner went off and came back. Space will be, I don't know, the ultimate joyride. It will always be something that only a select few will get to go. But I think in the next 5 years, that's going to change. But I see all these great conversations for rockets and living conditions and all of this. I'm still not seeing the changes that need to take place to have us survive, right? The whole reason this was called You Can't Get to Mars Without Me, not to sound completely egotistical, but what I do here at Movement Lesson, what I do for my profession as a movement specialist is, yes, I do work with children primarily with special needs, but my aha is that where a child can't move or you can't move if you've become special needs is the same that happens to an astronaut, right? What happens to their muscles? So the first thing when you get shot off in a can, the second you leave our atmosphere, you no longer have developmental milestones. What does that mean to you? You can't walk, you can't crawl, you can't sit down, you can't stand up, you can't feed your face, you can't do what I call functional but organizational movements. All of our movements are based off of opposing gravity, right? Gravity to us is not a pulling force. Now, if I knock this over, it's gonna fall, and yes, I'm capable of falling, but I'm not organized to fall down. Even if I come way over here or something like this, I'm not at a threat to falling down, right? That's not how I organize. This plant here is never going to organize to fall down. Now, you can say if I don't give it water and sunlight, but the key movement that's going to be missing out of its life that's going to cause death is lack of rotation. So you hear those words, it's going to cause death, lack of rotation. Now, I'm not talking about spinning a space station. Spinning a space station is now centripetal force. That's not gravitational force. So even if you spin it in such a degree that, let's say I weigh 150 pounds, and now on that spin, I'm weighing 150 pounds, that's not apples to apples. That's apples to oranges, right? I can do any kind of rotational movements in opposing gravity, whether it's eating, whether it's fixing my hair, something simple like that, to doing a cartwheel, something like that that's more visually appealing as to opposing gravity and using rotation. But just getting out of a bed, you need these principles of movement. And that's where I say my correlation with working with special needs was my aha, because that's exactly what astronauts are going through. So they lose their muscle mass, they lose all of this. And I get it, we can blame it on gravity, but we have to look at the stress factor is how we are unable to move, how we were unable to organize our movements in our bodies. So in my podcast, where it's called Movement 4.0, Babies to Astronauts, you can't, giving birth in outer space is going to need to include these principles. For us to sustain our bodies, our lives, getting to Mars is going to have to include these principles. So there's 21 theories of biological gravity in here. So what I talk about is gravity and movement. Now, I've had people come at me, I should say more physicists and so forth, saying gravity has nothing to do with movement. And I'm like, what do they teach you in school? It is essential on how any living organism organizes their movement is within opposing gravity, and to do so is rotation. You might not see it in this plant, but you could look at any plant starting as a seedling in slow motion, and you'll see this rotation just take off. It's just incredible to see. And when someone presents without being able to produce rotational movement, which is someone with special needs. So if you have a stroke, you're going to need these principles, right? If you have Parkinson's disease, you're going to need these principles. If you have cerebral palsy, you're going to need these principles. Hi, Lyra. It's just pure science. It's pure physics. Now, because this isn't a living organism, my T, right, anything that I do, it will counter to horizontal level, right? There's a mass response to buoyancy and to gravity. Yes, I'm a mass, but I'm a living organism. So I can counteroppose, and that's why it's different when we swim. So even to take the astronauts and put them into the pool, yes, you're saying I have too much buoyancy and not enough gravity, and I have no rotational movements, because that's what you're going to get in the pool. So you are simulating the movements that are needed in outer space, but you're already breaking down an astronaut's body before they even leave. And so we need to set up the proper assessment tools for each person. So that's something that I do here at Movement Lesson when I work with a special needs person. People go, well, you have to have protocols for cerebral palsy. No, I have to have protocols for Cindy. You know what I mean? It's how that child, baby, adult, whoever I'm working on, it's about how they organize movement in opposing gravity. It's just that simple. It's just pure physics. And so how that person is organizing their movements in opposition to gravity, because guess what? We're either opposing gravity or we're succumbing to it. There's no in between. We're not chilling out. So if we have cancer, right? Cancer now is a mass. It's a non-rotational mass, and you will start to see this. Diabetes too, it makes the system way too heavy. Our mass viscosity flow rate is just changed so much, and you'll see people literally fall asleep, and we can blame it on the diabetes. But when you look at the movements that have affected these people and how it's affecting their system, it's the rotation, the lack of rotation. My aha was still that space shuttle taking off. Escape velocity has it. But there's a difference between linear-based aeronautic rotation and torque versus a non-linear base, which is us, non-linear, and opposing gravity, right? Because again, I'm not taking off from the atmosphere on my own, like free jump. I need a rocket, I need thrust. But at the same time, you can look at any failed attempt of a rocket taking off, because a rocket will go straight. If it goes straight up, then Newton's laws take over. We're equal to equal, and it will crush the rocket. Now we can blame it on the O-rings, but that specific lack of rotational movement within that area will collapse the system. Same with us. And so that's what we have to look at when we're looking. So there needs to be, yes, space-based protocols for movements prior to takeoff, what we need to work on, because what we have to evaluate is where there's gaps of this information within the person who's about to have short to long-term space programs. I'd say at least if you're going up for 6 months or longer, you have to go with these principles. You just have to. Now, I did not go into what I would do for it in the book. Right now, I'm just cataloging all my principles of movement and opposing gravity. So there's going to be, a category for just in general, but then it has to be fine-tuned. I go into the vision, the fine motor skills, the gross motor skills, and where they're coming into play, milestone and synchronization, and how that person, and then what that person could do to improve prior to taking off. And then once they're in a space-based atmosphere, whether it's going to be on the moon, on Mars, or on a space station, what is their program for what we call exercise or movement formation in that environment? It can't be with spinning. Spinning just glues our feet to the ground, and our feet don't glue to the ground. That's not how we organize movement. Again, the conversation needs to be on how we organize movement. The conversation needs to be on when the organization is starting to fail us. We can blame it on the stroke, or we can blame it on old age, or we can blame it on I've been too lazy, I haven't been to the gym, lack of muscle. We can blame it on a lot of things. But the common movement denominator is within the rotational fields. And so either I have to come up and figure out more of a scale of all of this, or again, those evaluation techniques. I can evaluate you by putting my fingers on your back. But that's not everybody, and I've been using this forever. So that's a conversation that has to be had. We can't keep talking about these great rockets that are taking off if we can't keep someone in there to man them. Worrying about the astronauts needs to be our number one focus, because right now you're putting them into a womb-like environment in a sense, and they go into expansion mode. And it's a tad different than being physically back in the womb, because we have elimination now. We're going to the bathroom, we're breathing, which a fetal development doesn't have. But it's still in a frictionless environment. And that's where you get start seeing the bone growth, the eyes ripping apart and so forth. But in the sense, they're slowly exploding in outer space. And then when they come back, the rehabilitation can't be on muscle-based strength. It has to go back to rotation. Because remember, little old ladies can get to the supermarket just fine. They don't have core strength. It's about core movement integration. So these are the things that need to be looked at. But those are the conversations we have. Whether we're dealing with someone who's here on Earth and he's just having problems with neuromotor planning skills, which could be, again, we can declare that person having special needs or developmental delays, or again, has had some sort of trauma to their system. But to sit there and think that strength is the answer, just because you're strong doesn't mean you can move, right? And so those are where the techniques have to come into, again, for pre, during, and post evaluation for that person. So protocols are there, but they have to be there specifically for that astronaut. And it's not saying that men are different than women. It's just your life-based experience and then how it affects you. And that's where we're going after, because it's movement. But when the organization of movement in opposition to gravity fails our system, whether it's physically, because we've been traumatized, or because now we're in outer space, that's where we have to go after to fix or solve the problem. And so that's where I've been for the past decade plus, and that's what I'm trying to present and bring to the table. So these are the conversations we have to have. So it's save the astronaut, get them there safely, but we got to get them home, but we have to keep them where they need to be. But to just assume that they're going off to Mars and they're never coming back again, that's not the way to play the game, because we're sending over people that are double PhDs. They're physically capable of understanding these principles and working with them in a way to save their bodies, but they have to know they have to be able to do it. And that's what we have to show them. Thanks.